Hello children, you must be wondering what I am doing with this wire. You know, everything in electric current is actually related to this wire. What happens in the previous videos we have seen, one of the terminals of this wire is connected to the positive terminal of an electric source, and another terminal of the wire is connected to negative terminal of the electric source. And through the negative terminal, you see electron starts moving through the wire and it goes to the positive terminal. That is what is the basic concept of electricity, though there will be, when you go deeper into it in higher classes, you will try to understand about all those terms, electron drift, etc. But at present, for a very basic understanding, you try to understand that electrons do flow. Now the atoms and molecules present in this wire will be trying to hit the electron coming, because the atoms and the molecules, they themselves are a little bit moving in any of the, any form of matter. So what happens? So the electron will keep on bouncing, touching, hitting other molecules and particles which make this wire. And that is why when the electrons are moving from the negative terminal to the positive terminal, so the current flows, as we say, and the conventional direction of current is just the opposite. But the movement of electron through this wire is very important. The hitting of the electrons with the hitting of the electrons to the atoms and molecules which make this wire causes little bit slowdown of the electrons. That means little difficulty in the movement of the electron from one end to the other end. And that is why a wire offers resistance to the flow of current. So resistance is something which opposes the flow of current. Resistance is the property of any conductor to oppose the flow of current, and it's very natural. The electrons moving inside this is something like a crowd of people in a marketplace. They are the molecules of the wire, and the marketplace is the wire. So a crowd of people like moving in the marketplace at random, and heavily dense crowd, and in between you have to move to go to the other end, and those are the electrons. So obviously the ease with which electron will move from one end to the other end will depend upon how the crowd is moving. So there are different market. In one market there will be more crowd, in another market there will be less crowd, and in the one which there is less crowd, the electron movement will be little better. And in the ones where there is more crowd, the electron movement will be little difficult. Same thing, that means depending upon the market, your movement can be fast, slow or medium. Same thing happens depending on the wire, the nature of the material of the wire, the electron movement will be accordingly. And that is what is resistance. Resistance, again I said, property of a wire. It is a property of a wire to oppose the flow of current through it. And now what happens? So resistance will depend. Now I'm leaving this wire. The resistance will depend, children, on the nature of the material, because suppose I talk about the gold wire. The gold wire. So first point is resistance depends upon the nature of the material. Resistance depends upon, number A is the nature of the material, depends on A, nature of the material of the wire, nature of material. All right. For example, I'll tell you, that means gold has less resistance than copper, and iron will have more resistance than gold and copper. So why this difference is there? Because the make of this wire, their atoms and molecules, and the way electrons are moving through, it depends on how gold is made and how copper is made and how iron has the makeup. So how it is made, how its atoms and molecules are spaced and through which electrons have to move. Also how loosely the electrons of gold or electrons of copper or electrons of iron are able to move. So resistance depends upon the nature of material. As I said, gold will have lesser resistance, copper will have a little more than gold, but less than iron, and iron will have the highest resistance among them. So all the materials, there is a list from where we can obtain that which has got the highest resistance and which has got the lowest resistance. So that is one of the things. Now secondly, now as I said, electron movement through the wire, when it moves, then it hits the atoms and molecules of the wire. So that means, let us try to understand. I've got two wires of the same material. Now one is say for example 20 inches length, and another is say for example just the double 40 inches. Now if electron moves from this end to this end, so the wire will offer resistance, and if it has to move from this end to this end, the wire will again offer resistance. So where the electrons will experience less resistance, the more the electron has to travel, the more resistance it will experience, and the less electron has to travel, the less resistance it will experience. Therefore resistance depends on the length of the wire, provided the thickness of the wire is the same. So resistance B depends upon the length of the wire, and how does it depend? It is directly proportional. Longer the wire, the more is the resistance. Longer the wire, the more is the resistance. Why? Because the more distance the electron has to travel, the more resistance or the more opposing factor it will experience. Now suppose I take two wires of same length. I keep the length same. Suppose I take two wires of same length, but one is thicker and another one is thinner. Then it will become just the opposite. Try to see this. I am explaining this point. Number one is I am explaining this point, length of the wire. If two wires are of same thickness and electrons are moving same thickness, two wires are of same thickness, but one is double than the other, and same material, one is double than the other. Then when electrons are moving, then what is happening? The electron has to move larger distance here. Suppose I am making this little better. So that means resistance is directly proportional to the length when the thickness is constant and the material is the same. The longer the wire, that means the more is its resistance. But I go to point C, resistance depends on the area of cross section. Now here what will happen, children? Let us have a look. Resistance depends on area of cross section. So what will happen, children? Let us see. If I keep two wires of the same material, but one is very thick and another one is thinner, then what will happen? When the electron will move, and here the electron will move, then the electron will have an easier passage through the thicker wire, and therefore the thicker the wire, the lesser is the resistance. So resistance depends upon area of cross section. That means it is inversely proportional to area of cross section. Resistance is directly proportional to the length, and resistance is inversely proportional to the area of cross section. Here only in boards a lot of time questions are asked. Are two gold wires, the resistance of two gold wires will they have the same resistance? Because in Ohm's law we have studied resistance is constant. No. Two gold wire will have different resistance if they are having different length. Two gold wires will have different resistance if they will have different thickness. So that means resistance is constant, but it depends upon the length and it depends upon the area of cross section. So why we are using the term constant? If somebody asks you why we are using the constant, under what condition resistance is constant? So you'll say resistance of two wires of same material is constant only if they have the same dimension. That means they are of the same length and they are of the same thickness. Then it is constant. So remember this, anywhere if it is asked that is resistance constant for the same material? No. It will not be constant for the same materials if their dimensions are different. There is a condition applied. It will be constant only when they have got same dimensions. That means same, same length as well as same area of cross section. Then only resistance is constant. Second is the unit of resistance. As you know, SI unit of resistance is ohms. SI unit of resistance is ohms. Ohms, and it is denoted by like this, omega. Sometimes just to understand resistance, we use sometimes a reciprocal term, conductance. Resistance is the property of a material which opposes the flow of current, and conductance is the property of material with what is the electrons flow. So it is just reciprocal. Conductance is reciprocal term of resistance. That means a wire of lesser resistance will be of higher conductance, and a wire of higher conductance will be of lesser resistance. Same way, if a wire is of lesser conductance, then its resistance will be high. That means resistance and conductance are just reciprocal to each other. That means resistance is inversely proportional to the is just the opposite or reciprocal of conductance. This you have to remember, conductance. So I'll need some board space again. Now till here we have understood. So resistance is directly proportional to the length, and resistance is inversely proportional to area of cross section. All the questions we discuss here only. If there is a wire, say for example, if there is a wire, copper wire of length 5 meter and its resistance is 10 ohms, the resistance of the same copper wire with same thickness but double length will be 20 ohms, that to ohms. That means if the length will increase, the resistance will increase. If you keep the thickness constant and increase the length, then if you double the length, then the resistance becomes double. If you triple the length, the resistance becomes triple. Just opposite. Conversely, if you keep two wires of same length and you change their thickness, that means you suppose the resistance of, say for example, this is a wire, say for example, and the thickness you see, this is the wire, and suppose the resistance of this is 4 ohms. Now you make the area of cross section half, then the resistance will increase. For same length wire, the resistance will increase. So what did I say? Suppose the resistance of this wire, this length of wire, and this thickness is 4 ohms. Same length of wire, but half the thickness will be 8 ohms. That means the thinner the wire, the more is the resistance. Now I have got two proportionality things. This is number 1 and this is number 2. So I rub the board and I use some mathematical expression I derive. I come to some mathematical expression now. Here let us have a look. Resistance is proportional to L by A. Now I can write using these two. Then resistance is equal to rho L by A. So what is rho? Through a numerical we will try to understand first. What is rho? Through a numerical. Actually rho is another constant which is called resistivity. Rho is called resistivity or specific resistance. Resistivity or specific resistance. Specific resistance. Rho is called resistivity or specific resistance. Now I'll rub off the board because I've got to use some board space. Now let us see. What is specific resistance or resistivity? If you want to know, let us do a numerical. Suppose I have given a wire of length 1 meter and its area of cross section is 1 meter square. That means the wire will look like this. The wire will be in form of a cube, isn't it? Because area of cross section 1 meter square means length 1 and breadth 1. So this is the wire, say for example. So I try to use this to find out some relationship here. So resistance is equal to rho L by A. So I will have R is equal to rho 1 by 1. So R is equal to rho. Now when R is equal to rho, when you have got length as 1 meter and area of cross section as 1 meter square. So that is what is resistivity. What is resistivity? Resistivity is equal to the resistance of a wire. Resistivity or specific resistance is equal to the resistance of a wire whose area of cross section is 1 meter square and whose length is 1 meter. Alright, that is what is resistance. So it is expressed in different ways. Resistivity is the resistance between opposite faces of cube of the concerned material whose edge is 1 meter. Resistivity is the resistance between opposite faces of a cube of concerned material whose edge is 1 meter. That means gold resistance means a gold cube, the resistance between opposite faces of a gold cube whose edge is 1 meter, and so that means its length, breadth and height is 1 meter each. So that is what is resistance. So that is what is resistivity. And remember, that means resistivity is constant. Resistivity is constant because now we have specified the dimension, and we have told the dimension should always be 1 meter length, 1 meter breadth and 1 meter height. So that means now the clever question will come. They will ask you, suppose you double the length of a wire whose resistance is 5 ohm, you keep the thickness same. So double the length of a wire, whose resistance is 5 ohms and you keep the thickness same, then the resistance will double, it will become 10 ohm, but the resistivity will not change because the definition of resistivity is fixed for a given dimension. So the resistivity of a gold wire is fixed, and you know there are the resistivity table is very important. Resistivity table is very important. Normally the conductors have a resistivity equal to the order of 10 to the power minus 8 ohm meter. If that much is the resistivity, they are considered to be electrical conductors. Insulators will be having high resistivity. Their order may be 10 to the power minus 4 or 10 to the power 1, something like that. Then they will be normally insulators. Conductors will have resistivity in order of 10 to the power minus 8 ohm meter. Now why I am talking ohm meter? Because the resistivity unit is ohm meter. How did I get this? I got this with the formula. What is the formula? R is equal to rho L by A. Now I know the unit of resistance is ohm, is equal to rho, unit of length is meter and area is meter square. So meter cancel this out, this goes this side, so rho is equal to ohm. I am putting the sign ohm here and the meter comes here. So unit of resistivity is ohm meter. That means all the questions now very easily you can touch. If you stretch a wire, its resistance may change, but its resistivity does not change. So resistivity is constant for all the time. Resistivity is constant for all the time. Alright, this you have to remember. Alright, and then we will go ahead with more sums over here. Thanks a lot.